Okay, given any two vectors, you can form a plane. And for those of you in linear algebra, a little review. You're forming the plane by creating all possible linear combinations of the two vectors. Okay, and if you're in Calc 3, it's not going to hurt you to listen to the next little thing I'm going to say. So a linear combination of those two vectors, for example, might be -3 times vector A plus 4/3 times vector B, and I'm purposely, not necessarily picking, 4/3 is not necessarily a clean number. This is some real number. This is some real number. They don't have to, they can be 0 for a linear combination. It's some real number times one vector added to some real number times the other vector would be a linear combination of your two vectors. So it's some scalar times vector 1 plus some other scalar times vector 2. So our linear combination in this case would be -6, -18, +15 added to 16/3 minus 12, 8/3. So I add the like components, so -6 gets added to 16/3 would give me -2/3. You guys can help double check, but -6 should be -18/3, so added to 16/3 where I got -2/3. Then -18 plus -12 should be -30. And then 15 added to 8/3 would be 45/3 plus 8/3 would be 53/3. Okay, so basically you have two vectors. You could create infinitely many other vectors by adding any constant times one to any constant times the other. And if you imagine making all kinds of other vectors from the source, all of those vectors are going to lie in the same plane as these two vectors. And if you started graphing all of these different vectors, you would end up starting to span a plane. Your picture would start to look like a plane in space, okay? So I guess first concept is you should realize that given any two vectors, you can form a plane. So in Calc 3, we're going to try to come up with the equation of that plane. We learned last class that the actual slope of a plane can be identified by the vector that's perpendicular to the plane, the normal vector. So step 1, to find the equation of the plane, you need to somehow come up with your normal vector. If you want to kind of pattern it to finding the equation of a line in elementary algebra class, so if we were back in elementary algebra, and we were finding the equation of a line, step 1 would be find the slope. And then step 2 would be find the y-intercept. And then step 3 would be put it together. So in Calc 3 now, first we want to find the normal vector, then we identify a point on the plane, and then step 3 we put it together. So how are we going to find the normal vector in this situation? I have two vectors. I'm trying to find the equation of the plane that contains them. I need a vector that's perpendicular to that plane. What do I do to find a vector perpendicular?
You use the cross product?
I use the cross product. So, for this particular situation, finding the normal vector means finding A cross B. If you found B cross A, that would be okay too, because it would be a vector that just points in the opposite direction, but it would still be perpendicular to your plane. So why don't everybody right now take a minute on your own to try to find A cross B. While you're doing that, I'm going to try to graph our